Okay, guys, y'all look up there. So this is RSLogic 500. And the only programming language that it supports is Ladder. We'll look at the different programming. There's actually 5 languages out there that we could program with PLC. What languages are available all depends on which application you run. I can't remember exactly how many is available on the TIA portal that we have right now. I know function block diagram is available, and I'm not sure if I know structured text is not on there, but I think the 5000 RSLogix 5000 I think supports all the languages that's available. And what we're trying to do is they're trying to leave a path, so no matter what discipline you came up through in automation, you have a method of programming your robots, not even automation or technology. So, you know, if you're a computer programmer, you understand these text-based languages like Pascal and C and Java and those type of languages. So they wanted a language that those people could program in, right? Microprocessors, you learn a language called assembly language. So if you came up through that language level, then there should be a method for you to program PLCs without having to learn a completely different language. Of course, by far, the most prominent language for programming PLCs is ladder language, or ladder, what we refer to as ladder logic. Now, what they did with RSLogic 500, which basically revolutionized this technique of programming, was the first thing that they did was they have what they call dedicated memory blocks. So what they do is they dedicate some of the memory in the PLC for certain things. So these are the dedicated blocks over here. So these are we call them data files. So this is memory that's dedicated, and you can't use them for anything else. So the output data block just basically shows us the status of our inputs and our outputs. So right now I could look at this and I can tell all my outputs are turned on. Because if it was turned on, there would be a 1 in the associated bit, right? Remember. And of course also Allen Bradley PLCs works in groups of 16 bits. So notice all the groups, we have from 0 to 15 on the groups, right? You'll see that. We call them module numbers, but technically they might not be modules. So every group of 16 on an input port or an output port would definitely get another module number, right? Of course, the outputs on this one just run from 0. So when I turn on an output, I think I don't think I've made any changes. So this one, when we got it on run, if I was to come over here and I was looking at my output status, and as soon as I come over here and turn this thing on, then that output that I have assigned should come to a 1, right? Does that make sense? And of course, this is dedicated to inputs. But by the way, you can look at them in binary, you can look at them in octal, you can come up and look at them in hexadecimal. Okay, so this is just different methods you could prefer to look at them. Of course, to me, binary is easy to see. This is the input status, so we can come up here and tell the actual input status of our input. So we notice that input 1 is got a 1 and input 0 is a 0. And we can also force these guys. Here's the S2 register. This is the status register. So this, we can't do anything with this. But we do have some unique things that's available to us that a lot of, especially the textbook that we use, does not cover. And one of the things it doesn't cover is this free running clock right here for us. So instead of trying to use the cross-couple timers that the book teaches to generate blinking lights, so we notice we have blinking lights all over the place. Then we can come up here and we can use one of these these counters. We could run it through a counter and divide it if we needed to, right? And then every time it counted out. Here we could come up here and just use one of the bits. So it looks like this bit right here is blinking at pretty close to a second, right? Understand? So if I wanted a light to blink every second instead of me doing the cross couple timers, I could just come in here and use bit 11, right? Then put that as a normally closed or normally open input. This one we didn't talk about. This is called the first scan or first pass bit. This is so if I wanted something to happen every time I reset it or every time I turn my PLC on, if I wanted something to happen, this is the guy I would use. It's only executed once. That's when you come up and you reset your PLC or the first time you turn it on. So if I wanted to do something like that, then that would be the bit I would use. And it would be S1/15, right? Everybody okay? That makes sense. We didn't use that. I don't think we used it. I think we would play around with it with advanced PLCs. Not the first pass. We'll play around with this. So what's nice about the first pass is that anything you want to initialize when you first turn on that PLC, then you'll use that first pass bit. So, and we can come in and look at the processor. We can look at our scan time. This gives us the average scan time for this program, which is roughly 23 microseconds before it does what? Before it loops. We could come in and see if we have any errors with our math operations, which we didn't get into intro, and we won't get into this class, but we'll get into the high-level instructions if y'all take the advanced PLC class. Also, debug, examine, protection, force. This would where we come in, and we would enable and disable the force feature. What's forcing, by the way? Yeah, that's when you force an output, even though we take control away from the PLC program, and we can turn an output on, or we can simulate an input as being true or false. So we do that a lot when we're developing programs and we don't have it hooked up, or we want to force something. But guys, when you force outputs, you know y'all got to be extremely careful, and you got to understand the consequences of the force, because what's happened is you've taken away all the safety features that's built into those programs. All these sensors, monitoring the sensors, monitoring if somebody's present, monitoring that, you've taken that away. And you could literally kill somebody by forcing an output, right? Did I tell you about the US Steel guy? Yeah, we'd have to come back and do something else. Right now, by default, it's enabled. And I'd have to go back and figure out how to turn it off. Notice it's grayed out. Yeah, what you'd do is you'd go to the outputs, like we'd come over here to this output, and we would put it back on a binary, and I would come up here if I wanted to force this output. I would just come back and double click on it, and I'd put a 1. And the output turned on. Huh? I think what this is, it allows you to clear out the force, right? Or to reset it once it's in there. Are we okay? Of course, this is where our B3 files are, right? You understand? So this is where anything we need to use. Primarily, we use these for what we call internal coils, right? We have up to 255. The MicroLogic 1000, it's a fixed PLC. It doesn't do this. But what this guy does, it allows you to create other bit files. So we can come up and we can add another data file out here. Oh, it's in run. I can't do it while it's in run. But we can add another data file in here and call it like B10. And then we can use that as bit files too, right? We can use a CA. If we started off with a C, then it's dedicated to timers. If we started off with a T, then your new data file is dedicated to timers. C would be counters, right? You understand? F would be floating points, right? N would be integer numbers. So with the 1100, you can add as many data files. If you run out of space in your data files, So you got 256, right? 0 to 255, right? And if you run out of that, some of your PLCs will allow you to add other data files. But once you've added them, they're dedicated. So it does give you a little bit of control of the memory. You don't have any control over this memory right here. Your inputs, your output, your status, your binary, your timers, your counters, your control, your integers, and your floating point data files, those are built in for you. Even if you don't ever use any floating points, you've lost that memory. Right, you understand? If you never use integers, if you never do math, you've lost that memory. So what they've done on all your new PLCs is none of the memory is assigned. First of all, you have to assign the memory. So we'll look at that and see what we can do with that. So are we okay? So there's no status. So we to get access to the status file on the 1200, we have to assign a memory area that we can access. So that's a big difference, and you can understand why. Because that takes away the control of the memory from the application and gives you control of the memory of the machine. So you don't have to add more. You don't have to add more memory files. So if you, on step 7, you can set up counters, but what it does, there's no memory assigned to counters, but as soon as you create a counter, it assigns it a memory block. That makes sense? Okay. So this is basically the biggest here, huh? Well, this is the last version that we have. RS Logic's 500 is basically still out there all over the place, but Allen Bradley's not supporting it anymore. So there's really no more updates to 500. 5000 is what they've gone to. RS Logic's 5000 is what they've gone to. That's the latest version of RS Logic. This, the 500 supports, first of all, the only language available in 500 is ladder. So everything is ladder. You can't do any other languages of that. And then, of course, 500 basically controls the memory, most of the memory for you, instead of you giving the option to control your own memory in your PLC. 5000 also is a tag-based application where this guy is not. This guy, you can assign it an address and you can leave it alone, and you got to figure out. So on this one, you have to assign it a symbol, right? You understand? And no, that's not optional anymore on our PLC. You have to, now 5000 requires a tag. The Siemens, if you don't give it a tag, it will assign it a tag. But it'll give it 1, 2, 3, 4, 5, 6, 7, and it'll just keep implementing that, right? But just using tags that are automatically assigned don't make sense, because then you got to keep up with what tag one is. So you need to assign it some type of little mnemonic, right, which is a memory jogger, so you can pick it up on that. And what's really nice is on this one, once we've assigned it a symbol and it's still true, then I can type the name of the symbol and it would automatically insert the address for us. This is why in Intro to PLCs, I basically required y'all to use what? Symbols, so you could get used to the new PLCs using tags. So your new versions add additional programming languages to support other languages. They are tag based, and they take away the control. They take away the control of the memory from the application to the user. That's the big difference. So that's a good question. We got it? Okay. So when we look at the 1200, this garbage over here is not over here. In fact, on 1200, the project tree is still on the left, in fact. And then your instructions, everything's on the right. And on this one, if we want to create a subroutine, we would just come up here and I'd have to have it in offline. So really do anything with this. And 5000 allows you to edit online. It's really cool. So you can come in and you can create, it keeps the old version, and then you can come in and create a new run and make corrections on it, check to see if it's okay. If it's not okay, you can just tell it to go back to the original run, which is pretty cool. So 5,000 allows online editing of the program. You can do online editing. 500 does not let you do online editing. To edit a rung, you got to do what? You got to go offline and then edit and then upload it, download it. Huh? I don't know. So we're offline. So Willis. So here we insert other rungs, same way, right? Of course, Siemens don't call them rungs; they call them networks. And each network's got its own window. And automatically on Siemens portal, it puts a little text box up so you can type comments right off the bat. Yeah, you can type comments. You can type comments, and we'll do that too. But we won't. Y'all don't have to type the German. Y'all can type the English portion of that, right? Notice this one automatically gives it. So it was this, and then we come up here and put an out for it. And check for errors, see if it's okay, it's okay. And then we would download it, right? And here, what you probably need to do is assign it a different version number. You can hear it automatically. So this would be a really good thing to flash lights with or do something like that, right? Instead of trying to do the cross-couple timers that we use. Okay? But this is built in. Siemens, you have to specify, we'll show you how to do that, how to bring in all your clock signals. We'll have to dedicate memory to that too. Are we okay? Okay. So what this, these are the mounts that we're going to be using.